Good afternoon, everyone. Welcome to the first talk of the security seminar here at Purdue University. This is also offered as a course, CS 591S. And if you are taking this for 1 credit, then what you need to do is to sign your name at each lecture when you attend the lecture. If you miss less than 2 lectures, then you are fine. You'll still be able to pass the course. If you miss more than 2, then for everyone that you miss over 2, you have to watch a DVD of a lecture you missed and then send a summary of the talk to me. So that's the policy for this course. And today we have Dr. Steve Elliott from the School of Technology to present. He's assistant professor of industry technology here at Purdue, and his research interests are in biometrics, signature verification, mobile computing, electronic and mobile commerce, and logistics and supply chain management. He has been involved in a number of activities related to biometrics. In particular, he's actively involved in setting the standard in biometrics. He's involved in the national body for setting the standard. So here is Dr. Elliott.
Thank you. Okay, good afternoon. I'm going to be talking today about biometrics. How many people in the room know something about biometrics? Kind of see where I'm heading. I know you two do, so. All right, cool. Excellent. All right, so who am I? I guess that's one of the questions that we're going to be asking ourselves today. And how do I know that I am who I say I am? And would you know me from my fingerprint here if I just put this up? A couple of people from a trust and privacy class I recognize. Do you know who I am if I just got my fingerprint up there at all? Not at all. So for those people that think that biometrics maybe are all identifying, if I just put my fingerprint out there, I might not know who I am unless I tie some data to me. So in some respects, and we'll probably cover this in a different class, some people argue that this is actually privacy enhancing. So we're going to go through today and examine some of the biometrics. We also have a website available for you to go onto, and I'll post the slides, or I'll send the slides across for them to get posted in multiple areas. So if you have any other additional questions, let me know. I guess in the first stage of discussion, and I teach a biometrics class tonight, in fact, I'm going to pose this question to my students and ask them, how do you know that I am who I say I am? How do you know I did not send a false bio across this afternoon or last night? How can you prove that I am the right person? And then after all of that, what kind of credentials do I use to tie my biometric to that identity? You may have various different identities. In fact, I have 2 legitimate ones in my passport that I should have brought along, but I have 2 different dates of birth in my passport, both on legal documents. So that's always very interesting. And then the second question is, am I who I say I am? So if I say I'm Steve Elliott, you've got to go out there and prove it and find out the root document or the seed document that actually justifies who I am. And eventually, I'm going to tie that into a biometric. So when I travel into the country every so often, I put my fingerprints down, I give the immigration people my picture of my face, and then they have to go and authenticate it against my passport, and hopefully they choose the right visa in there to make the right call. So biometrics basically is one way of identifying an individual's identity. There's many other ways of doing it. As you're probably aware, there's a token, something I have. All right, we all have some form of credit cards, magstripe cards, RFID cards, either a secret or a knowledge, such as a PIN, what I know, and what I am or what I do in terms of a biometric. All right, and we all have various biometrics. We don't always have the same biometrics, and this is one of the research challenges that we have in biometrics, is trying to pick a biometric. Which one do we have that we all consistently have? That's not an easy question. It may sound pretty kind of a stupid question, but we don't all have good fingerprints. We don't all have 5 digits on our hands. We may not have an iris. We may not have an eye. We may have just 1, not 2. We may have no voice, we may have a voice. There's so many different combinations, and we've got to pick the right biometrics. So that's always a particular challenge. We typically go for face and fingerprint for immigration, and that itself provides quite a lot of challenges as well. So what I am, what I do, all parts of biometrics. We use biometrics every day, although not in the kind of the technical sense, but typically we use biometrics. For example, I'm kind of learning people's faces. I don't have a name to most people, although I've seen a couple of people before, and I've seen at least 3 people here that are in SPAF's class. And so I'm updating my template to kind of figure out who you are, and that's the same way a biometric goes along. I see an image, and I kind of load it up into my database, and if I'm walking around campus, I'll kind of update it. You'll probably recognize me if you're in CNI, if you're in the College of Technology. And you'll probably recognize me where we have Labe in Bering for this privacy class. And if I see you at the rec center, I might do a double take and say, I think I know that person over there at the rec center. And I'll update my template and information to say, oh, they're also at the rec. How many people have gone to a different country and recognized someone that they thought was very similar to someone that lived just down the road or they've been to college with? You kind of do a double take. All right, we always do that. I was in Seoul, and I could have sworn blind that I saw someone that I recognized from Purdue, and that's kind of on, but they were wearing a Purdue t-shirt, so that was my first giveaway. And then I recognized them, I actually had them in the class, and that was very unlikely. I don't know why they were there. They certainly didn't come from there. They didn't live there. They were on a conference, and it was a different conference to what I was on, and I wouldn't have put them there. And so then I had to update my template. I kind of took a second guess, a second look, and said, I recognize that individual. I'm going to update my template. The more times that I recognize an individual, the better my template goes, and the easier it is for me to remember an individual. If I had a student 2 years ago, I might remember who they are, I might remember their name. But if they just came once a week to my class, I'd probably say they were familiar, but I might forget their name and their associated data. Biometrics works in the same way. The more times you visit a particular sensor, the more updating we can do, the better we can train the algorithm to learn you and figure out the different intricacies, and then we can go ahead and improve our performance. How many people here have an account with PEFQ? Keep your hands up. How many people here have used the fingerprint machine at PEFQ? A couple of you. All right, so initially we'll take a look at your fingerprint, and as you go on, it will update the template. If you go ahead and use it once a year, your performance may not be as good as if you use it once a week, all right? Because your fingerprint may have changed. It may have got a cut on it, your skin may be dry, the weather may be different. If I take a fingerprint of you today, your skin is likely to be very moist. It's hot out there. If I was to take a fingerprint with you in December time, when it gets a little chilly here, and maybe, February when it gets very chilly here, then your skin will change, and your fingerprint will change, and your performance of that fingerprint sensor will also change. So there are a lot of variables that we need to discuss and figure out. But we basically use biometrics every day. When you're on the phone, you would listen to someone's voice. Now, what trips up you in recognizing an individual? What factors will trip you up in recognizing an individual? Anyone spoken to someone on the phone and thought it was someone else? Okay. Until you make a mistake. All right. Something else.
It's a dark room.
Yeah, if it's a dark room, yeah, I might not recognize them. Or if I'm in a different location and it's dark outside, I walk down the street and see you coming out of the bars or whatever. It's a little early in the semester for that, I guess. But if I see you come out of the bars, I might take a double take, might not recognize you, it might be a little dark. Something else. Other factors. How many people know identical twins and can tell them apart?
Hairstyle or clothing changes, color, hair color.
Yeah, that's right. I associate, when we do the global features, we look at you as your face. If all of a sudden I come in with a beard or something, you might laugh, but then you might take a double take and move on. Or someone takes their beard off. That's kind of interesting. Aldine, it's on TV now. Aldine came back with a goatee, and it was gray. And, well, the rest of it doesn't have gray hair. So we took a double take. Is that really you? And it was. So different changes to different people will also affect the biometric. If you go and enroll in face recognition, for example, and you either lose weight or gain weight, and you haven't updated your template, that will affect the performance. If you go ahead and go on spring break and you come back nice and tan because you've been somewhere nice and sunny and not here, then that may trip it up as well. If you change your hair or do anything, change your appearance, you could go ahead and affect the performance of a biometric. So visiting it regularly also provides you with an increase in performance. So we create an initial image, we update it each time. In this case, we come to class, I see you guys. I'll be sitting in every so often in this lecture, I'll update my template, I get to know. Some people may drop out, and then I might see them on campus and recognize you from this class. We may recognize other people. We put you and a building together. I might see you in Kenai. If you swing by my lab, then I'll update you so you know where I work. And biometrics works in a very similar way to that. It's called template updating. Bertillon used this idea of using body measurements to identify an individual way back in the late 1800s. And he looked at your face, for example, and plotted the distances between your eyes to your nose, the nose to the top of the lips, lips to the bottom of the lips, and all the way down to your chin. Took ear measurements and so forth, and built up kind of a template or a database for criminals, and wanted to know basically whether that individual had come by again. And we use that today to try and build on an identifying trait. So biometrics is defined as the automated recognition of individuals based upon their behavioral biological characteristics. And that's pretty much the definition that we've come to, although if you read in the literature, every different article pretty much has a different definition, but all beats around this kind of bush here. DNA is not a biometric yet, all right? It is not unique to an individual. You may share the same DNA if you're an identical twin, and it is not automated. You have to have some person go ahead and do something to that sample and collect it. So it is not a biometric in the strictest sense of the word. But what is? Anyone suggest to me what the list of biometrics are? What are some biometrics?
Fingerprints.
Fingerprints is one, yeah. Iris. Retina. Voice. Face. Veins. Yeah, vein recognition, yeah. In fact, hopefully we'll get a vein reader in our lab this semester or next semester. It's pretty cool. Anything else? Hand geometry, yes. Not only the shape of your hand, you can also have two-finger geometry as well. They use that in Disney World for access control. What else?
How do you walk?
Gait, yeah, how I walk. And that is especially for locating people at a distance. When we want to identify an individual, we can tell how they walk. Might not be able to get them, but we might be able to exclude someone that's wearing a backpack, for example, or something that's heavy or awkward when they walk from a distance, and then we can change modalities later on, yeah, gait. Anything else? Huh? Keystroke dynamics, how to type?
Scanning the structure of the blood vessels.
Yes, blood vessel analysis, veins, yep. Odor is another one. Okay, you each have a characteristic smell. All kinds of things. Anything that you have, pretty much we can do some form of recognition on it. And each person really must have this specific biometric trait if you want a universal biometric. And that's something that is important. Many of us may not have, if you work in a manufacturing environment or you're just clumsy one day, you may not have all your fingers on your hand. I don't. Hand geometry doesn't work very well for me. All right? So although I have a hand, I don't have all the fingers for it to work properly. So that's one thing. I need to be distinctive enough from someone else. And here comes the difficulty with identical twins. Although Delane Vision, which just recently got taken over by Identics, took their algorithm for skin recognition to a mall in Minneapolis and said to identical twins, we give you $10,000 if you can fool our system. And they got some takers, but they didn't give any money out. And that looked at skin. Your skin is a lot different. And there's two ways of doing skin. One is skin spectroscopy, where we actually send some light into your skin and it will bounce back. And then there's surface texture analysis as well. So we've got to be distinctive enough from other people, otherwise we're going to get a lot of false alarms. Biometric system can operate in two different modes. First mode is verification, and the second mode is identification. Validates a person's identity by comparing a captured biometric already stored in the system. I'm trying to verify who you are, and Typically, this is done in a one-to-one format. It can also be done with a pin, so it's not specifically biometric related. You can have other forms of verification of an individual. Sometimes known in the literature as positive recognition or positive identification. And the simplest example of that is access control. To get into the lab over in Kenai, you need to give me your hand. I will enroll your hand into the database. You'll type an associated PIN with it, and then you type your PIN in, stick your hand in, you get into the lab if you've got enough, if you're in the right time to get in. So for example, we have over 120 students use the lab for an undergrad class. We restrict their access due to office hours, and just we don't have enough machines. There's only 12. And so we give them different time periods where they can come into the lab. Grad students can get into the lab all the time. And so it's one-to-one. Your hands are not that different from everyone else's hands for it to be a total identification system. So we give you a PIN. It goes ahead and pulls that template up, does a match against the two samples, and then goes ahead and gives a return score, either a yes or a no. That yes or a no can also be varied depending on whether it's secure enough or not secure enough, depending on where a system administrator would set it. And we're going to come on to that in a minute when we look at errors. In identification mode, typically, and it depends on the algorithm, but typically systems do a search on everyone in the entire database. And you don't claim any PIN or anything else like that. You will stand in front of the sensor and look at it if it's a face or an iris, and you let it capture it, and then it runs through the entire list and will return back either one or a candidate list, depending on what mode you have it in. So for example, if you go to an airport and you're in a watch list mode, it will go ahead and look at you. You make no claim to an identity. As you walk through the magnetometer, it'll take a picture of you and will run you against a watch list and will return back scores. And it may show that you look similar to someone that they're looking for and will return the list. And then the person that's checking off will go ahead and make that determination. So it will screen you, so to speak. So that's one way of doing it. So we can get into candidate lists as well. We also look at the question of whose biometric data is this? I've got the person, I have them in the database or not, and I want to make sure whether they're there. And the purpose here is to prevent a single person from having multiple identities or aliases. In some cases, it's not a problem to have multiple aliases. It may sound, in some cases, if you want to use a system and you want to get in, and biometrics you can have in verification mode, you can have multiple different pins. And that pin is kind of like the primary key to the hand. Whereas in this case, your biometric is the primary key. We don't want more than one person gaining access to it. An example would be border control. If I'm going to tie my finger to my identity, I don't want more than me coming in. Another example would be in the UAE, they have an iris recognition system where people that cross into the UAE have to go ahead and give their iris. If they have crossed into the border illegally, they'll take a picture of their iris and send it back home. Typically, they'll turn around and come back with different documents, but the eye hasn't changed. So then kick them back out again, and this is a recurring thing. In Afghanistan, they're using it to repatriate people back into Afghanistan for food, for the UN refugees. And when you get your food, you then look at an iris camera. We don't have any identity of you. We just have your picture of your iris. And there's your food package. Come back tomorrow. Don't come back the same day. We'll know because your eye would have been in front of the camera before. So that's kind of an identification mode. A biometric system looks like that. And it is the same for every biometric. So once you've kind of mastered this diagram, pretty much everything is simple after that. First of all, we basically make a presentation to the sensor. That is either putting your finger on, putting your hand on it, looking at the camera, doing whatever it is to capture the biometric. We grab the sample, we segment it, and we do some extraction of the features. For example, for fingerprint, I might want to extract the minutia points. Most of you have probably seen CSI or the Discovery Channel, where you see a fingerprint and all of a sudden a bunch of red dots or orange dots are associated with some features on that fingerprint, and then they go run the search on that. That's called just feature extraction. We want to take a look at quality control as well to see whether that finger is of sufficient quality, that we've extracted all the correct features of it. We found in our research that the elderly, for example, have very poor quality fingerprints, and as a result, their performance may be a lot worse than regular individuals. Well, 18 to 62 is our group, and then 62 and older. And that's an issue because last time I checked, people who are old also traveled. They travel quite regularly. So if I put my finger on the sensor and it doesn't let me into the country, then that's going to be a problem. So we need to take a look at algorithms that look at extreme populations. And we do some work in the lab on that as well. If this is the first time you've been into the interacted with the sensor, we create a template. That's basically a number of images, probably averaged. That, again, depends on the algorithm. And we store that in a database. We may store additional information. We either store the fingerprint, or we may store the fingerprint plus the PIN and some metadata as well. It all depends on your system. And then once you come back, you'll go through again, and we'll pull that template out of the database if we know who it is, and if not, we'll search through all of them. We'll get a match, and the match will give us a similarity score. And from that, the system will then make a determination whether to let you in or not. All right? So we get a threshold. That's kind of the hurdle, so to speak. And if the score is greater than the threshold, we'll let you in. And if it's less than the threshold, we won't let you in. That's typically how it works. Sometimes it's flipped, depending on the algorithm. Then we let you in, and then you do whatever. There's some errors associated with that. For example, we might not let you in when you're actually the genuine person, or we'll let you in when you're not the right person. And those errors are something that we want to minimize, and there's ways of doing that. One is to reduce the threshold, so you let everyone in. That's probably not a very good solution. Or the other way is to maybe choose a different biometric or fuse 2 or 3 biometrics together. There's software out there now that does lip, face, and voice. And then we can weight the different characteristic modalities depending on whether you have good characteristics in face, good characteristics in voice, or good characteristics with your lip movement. So there's plenty of ways of doing this. But this is the general biometric model. Any questions on this? Okay. Now, typical question I get all the time is, which one is the best biometric? We do a lot of implementations over in the College of Technology trying to figure out which one's the best biometric. And the best answer is, I'm not going to tell you, it's a big secret. And the reason is because I don't know the best biometric. You can take a look at performance characteristics, in which iris looks pretty good in most of the curves that we present, and I'll show you them as well. But all biometrics have their strengths and weaknesses. One project that we're working on this semester is to secure the hangars out at the Purdue University Airport. And we want to know which ones, what do we secure them with? Now, we may end up just securing them with an RFID card because throughput there is an issue. We need to get, a batch of students through the door relatively quickly, about 50 students through one door in a fast period of time. And probably the best way maybe to do it is just with a simple prox card where you just walk through the door and it lets you in. With hand geometry, which may be what we end up using, it really depends, you've got maybe a 2-second throughput for each person. You've got to type your PIN in, stick your hand in. For face, you've got to look at the camera, which means no one else can be waving and doing silly stuff behind you, which we've had out there. So no biometric is really optimal. It really depends on your population and what they need to do or what their desire is to get through into that system. For example, if I want to claim some benefits and I'm using fingerprint recognition, I'm going to present my finger properly the first time because I need my money. Same at PEFCU's ATM. You're not going to put the wrong finger down. You're not going to move your finger around. Likelihood is that you want to get your money, you need it right away, and you'll put your finger and behave in the appropriate fashion. You want a particular outcome. However, if you don't want to be detected by face recognition in an airport, you'll likely put your head down. So we need to figure out the application that we're going to be using to figure out kind of the psychology of the user that we're doing. We have this project. How many people go to the rec center? 1, 2. Okay. Got a fit class here. All right. Well, the rest of you, if you do happen to go to the rec center and work out, there's a hand geometry reader on the front door. And you may have noticed it. Now, we have some gaming attempts where students will just go ahead and play with it, just to do it, which is fine, to interact with the device, make the lights go off, and there's no alarms or anything. There's absolutely no reward for playing with the device. But we find that several people a day will just play with it. You don't get into the system. It doesn't get you through the rec center any quicker than doing it normally. But we'll find some gaming attempts. And so that's kind of interesting to see how people interact with the device. When we had face recognition out at the airport, we found that people would go along and cover the webcams where we had face recognition because they didn't want to be on the cameras. And quite a lot of them were staff members that just didn't really want to be on the system. Now, we marked out on the ground, don't walk here. If you do walk here, you'll be actually captured. You won't be verified or anything. We do that offline. But they could have walked around, and but they just covered it up or moved the camera or did something like that. I was talking to a company in the UK this morning about doing some signature work, and we were collecting signatures, and they're like, well, actually, it's very interesting. We collected a whole ton of signatures in the lab, and we did some analysis of them and tuned our algorithm to these signatures, which is a logical thing to do. And then we took it out to the bank, and people signed differently when they were signing their mortgages. The signatures were a lot more serious because the documentation and the intent was a lot more serious than just signing their signature to get their $15 in the lab and to get out of there relatively quickly. So again, you have to assess your population, and each one of them will react. So let's go through some modalities. The first one is face recognition. It's probably the most common and used by humans. In the legacy systems, it's used in immigration just because every visa typically has a face associated with it. Applications run from mugshot verification. If you take 581, we have an armed robbery videotape, and we look at video quality and so forth, and we found that this video quality is extremely poor. We can't identify anyone, and they look at the camera, which is really quite disappointing. They see the camera, they look at it, they tell everyone else in their group that there's a camera. They all look at it, so you should be able to do some form of face recognition on it. Not the brightest characters. They look at it again, and they stare at it like, wow, there's the camera. And I don't think anyone's twigged that it might be recording anything. And they then commit the robbery, look at the camera again, and then they destroy the camera. So you would have thought you destroy the camera first, then commit the robbery, but never mind. And so they tried to do some analysis of it. They sent it to our lab to see whether we could do some facial recognition because they were staring right at it. And I have my candidate list of individuals, my rogues gallery, and we couldn't do anything with the image at all because the video quality was so horrible. He kept on going over the VHS tape. He had the really ideal situation where everyone stared at the camera, but our face algorithms could not extract it very well because the image quality was so poor, because I don't think he changed the videotape since he installed the system. And he just kept overplaying. Now with DVRs and all of that stuff, that will get rectified, but that costs some money, and he just had a VHS tape. So that was kind of disappointing to us that an advanced face recognition algorithm couldn't figure it out, especially when you had such an ideal candidate set of people staring at it for seconds. It was very frustrating in the class as well. They're like, what's going on? Now, the other one, the more difficult one, is dynamic uncontrolled face verification, where I'm just walking around and they need to grab your face for whatever reason I want to do that. And one example would be in the subway system in London, where we see that we can capture your face as you walk through the system. It's uncontrolled. You're not looking at the camera, typically, and they're everywhere if you've ever been over there. We can do it two ways. We can do it based on location or shape of your face, looking at your lips, chin, and whatnot, or we can just take a generalized viewpoint of your face and go from there. In order for it to be successful, we need to detect whether a face is present. That may sound kind of redundant, but if you're standing by a domed window or a circular window, every so often it may jump over to that window because that's also circular and it's looking for a global feature. So the algorithm sometimes may jump over and look for something that you clearly know that it's a window, but it doesn't, and it will jump over there every so often. So that's somewhat of a challenge. So if you're doing face recognition, make sure you don't have anything that looks like a face behind you, like just a drawing of a smiley face will sometimes trip it up. Okay, so it's something sometimes very simple. And we try and locate the face, and then we recognize it from a general viewpoint. Typically, full front on is the best one. We have 2D face and 3D face. 2D, obviously, you look straight on there. It's kind of a mugshot photograph. This 3D face is pretty cool. We can actually rotate the faces in our lab, so we take a 3D picture of you. It takes about 10 to 15 seconds to actually capture the image, and then it takes about a minute and a half to process, which is quite a long time. But we can rotate, zoom in, zoom out, do all kinds of fancy things with this image. And the performance does increase considerably. face recognition does have some problems. 50%. If I take a picture of you in this environment, kind of take you outside, and it's a little darker, let's assume it's wintertime, the algorithm could trip up by nearly 50%. That's a towing cost. So there are some issues, and 3D face sometimes can rectify that as well. These are the features we're looking for in 2D. These are the features, it's kind of hard to see, but it's a grid, kind of an overlay in 3D. So there's a lot more features that we're grabbing out of that. It's a little more computationally longer. Fingerprint, ridges and valleys are meant to be unique to each individual. And if we have multiple fingerprints, it provides us additional information. For the US visit, you need these two. For some welfare, they'll take all 10. They'll definitely take all 10 if you've been pulled over and you need to go visit someone in jail. The issue there is how many fingers does it make to be unique? I mean, that's one of the issues. If I'm going to design a database to enroll the entire population of the US, do I know that everyone is unique? And second of all is, how many fingers do I need to know for uniqueness? So I don't have everyone's fingerprints, so I'm taking a guess that these two are okay. But it's just an educated mathematical guess. I might need these two for 2 times 2. Either way. All right. This is what we're looking for in minutia-based fingerprinting. You've probably seen all of these before. The red dots here indicate minutia points, and we extract those features, and we get rid of the fingerprint, and then we just keep those features. So many times people when they look at biometrics think we keep your images, and typically we don't unless we want to keep them for research. Typically we just extract and throw away and keep the points of interest that we're looking at. These are actually fake fingerprints we've created. There's some software out there, and this is another ethical issue, I guess, that might be interesting to look at. But you can create fake fingers, and then you can create fingers, real live gelatin or whatever fingerprints from that, and then we try and spoof sensors in our lab as well. This is publicly available software, but it kind of shows you if you ever take a look at your fingerprints, the left loop, the right loop, the whorl, arch, and tented arch, the 5 characteristics of your fingerprints. This is Henry's system of classification. This is a fingerprint, obviously, and this is an extracted fingerprint. That triangle there indicates a core, delta point. The square there is a core, and you've got these little minutia points floating around. If I delete the green, I'm just left with those points, and I just stick them on a Cartesian coordinate, and that's my template. You might be able to see some dots in these ridges here. Anyone can see them? I don't know whether it's too dark. Those are pores, so we can also do poroscopy as well. Again, that depends on a lot of factors with your skin. That, by the way, is a very good quality fingerprint. If you go onto our homepage, you'll be able to see a very poor quality fingerprint. And it has about 3 times the number of minutia points. The best thing about this fingerprint is these minutia points are relatively constant. So we create them, then we see them again, then we'll be able to make a match. On elderly fingerprints, for example, these minutia points are all over the place. Hand and finger geometry, based upon measurements of the hand. It's the most successful biometric installation around the world in the commercial side. Obviously, fingerprinting for law enforcement is the biggest slice of the pie, but outside of law enforcement, hand geometry has by far the highest number of installations. The limitation is market applications and size of the device. And we also have some aging issues that we're studying as well. These are the points that we're taking. There's about 91 in hand geometry. And this is the device. And this is what we have outside. You can see that you have to align your hand with the pins down here. You enter your number in the keypad. There's the camera points down, takes an image of the hand here. And you can see to the right up there, then there's an area where you can take a side image as well. And so that is hand geometry. Gets a couple of issues with that. First of all, people don't know how to squeeze the pins. It's not always logical to them. But after training, we typically explain to individuals that it's like landing a plane onto a planet, and you just squeeze, just zoom in like that. It's a lot easier to do that with the device. It looks a bit silly like this. Zoom in and squeeze the pins. Elderly have a lot of problems if they got arthritis or rheumatism or something like that. I can't squeeze the pins too good. All right, so we're looking at that in our our extreme population study. People with missing digits might not be able to hit all the pins, and if you've got small hands, you might not be able to reach the pins. So those are some of the issues there. You can get around this. If I break this hand upside down is identical. Your left and right hands are mirror images. So with hand geometry, so that's always, if you break this one, you're not kind of out of luck yet. Right? They only make them in the right-hand variety unless you want a parking lot application where it would be kind of hard to stick your right hand out the window. So they do make them for lefties in that environment, but that's about it, special order. These are relatively cheap, about $1,500 to get a hand reader on a door. Iris recognition is the difference between a pupil and the sclera, and it carries very distinctive information. I got a couple of pictures for you. This is a side view of the eye. You've got the iris here as the colored area. The cornea and then the lens is on there as well. But basically, we need to extract these features. So we take out the pupil, we take out the white of the eye, and then we're left there with the iris in the middle. And the very cool thing about this is we basically take that circle and make it a straight rectangle. And then we basically filter the different colors from that to get an iris code. And that iris code, I actually can draw on this, right? So this iris code here is that eye there kind of split out and put in a straight square. And they take the functions of these colors here and stick it back in there. So that's pretty nifty. It's very cool stuff. I'm tapping the screen to undo. There we go. So that's an iris code that was invented by John Dogman. It's typically only one algorithm out there, although the US government just recently issued a call for more algorithms to be developed under the ICE program with NIST. And so that'd be pretty exciting to get academics out there to do iris recognition. These are several examples of different irises. You can see how colorful they are, although again, when we look at them at a grayscale. But these are some features of eyes that are, this is from John Dogman's website if you want some more information on that. But they're very feature rich. Keystroke dynamics, behavioral, indicates how people type on a keyboard. We've done some work in the lab on keystroke dynamics. We're also looking at spontaneous passwords as well, just trying to figure out what you're going to type, and doing a number of things over there. Keystroke dynamics is somewhat limited. You've got two variables typically that pop out, the key that you pressed, the key time, and the key interval. There's not a lot of information there, as opposed to an iris, which has loads of information on here as well when you extract that. Odor, made up of a series of chemicals, and typically this is going to be used in a security environment where we put a puff of air across you and there'll be a series of sniffers on the other side. We'll analyze your chemistry from that. Retinal is a rich structure at the back of the eye. Anyone that's been to an optician and had their retina looked at will know that it's kind of a blinding sensation. You kind of walk around with a couple of blue dots every so often for the rest of the day. So it's relatively difficult to capture, but we've had success in capturing retinal on animals. We've been doing some horse data collection. We've collected data on sheep, goats, and cows. And they have very good retinas, not very good irises. So we can go back there. And in fact, some of the work that's being done over in ag education is in 4-H. So if you know anyone in Indiana that's 4-H, they'll start to collect retinas from animals for the competitions that they have running on. Signature uses variables linked to how an individual signs their name and is a behavioral biometric. I can change my signature. So again, some underlying variables may be the same. Many people don't like it. They say it's a fairly weak form of biometrics. And each semester in class, I try and have people forge my signature. And I collect 91 variables of that signature. So if you get it graphically right, you're not going to get it dynamically right. Right? You might not get my speed or my number of pen up, pen downs. And we've all known someone that's forged someone's signature sometime. And it really depends on the level of knowledge. How many people here forged their... How many people here know someone, because it's on tape, that could have allegedly forged their parents' signatures sometime during high school or grade school or something else like that? And I'm going to stick my hand up because I did it a couple of times. What did you use? You used your graphical. You probably traced it, right? Or you kind of went over. As long as it looked the same. That's all that matters, right? If you do it electronically, you could look the same. Someone could trace it, but you're not going to get their speed or force or pressure typically. So signature verification can be pretty good. Drawbacks to that, different digitizers, you're not used to it. How many people signed on the UPS brick? Yes, your signature doesn't look like anything at all, does it? Doesn't look like yours at all. So the digitizers there sometimes are a problem. And voice, it's a combination of physiological and behavioral. There's obviously some issues with voice. If you've got naturally speaking by Dragon software, sometimes it doesn't pick everything up. It may be problematic. We've been testing the differences between landlines and cell phones. Performance drops dramatically. I shouldn't say drops dramatically. The curve drops exactly down. It's kind of interesting between cell phones and landlines. And again, depending on service carrier or your phone, different makes of microphones and different phones. Sometimes the cheapest phones are sometimes better at this. And fusion. When biometrics, we want to combine them, multimodal fusion occurs. This is a great area of research that we're looking at working with people. Right now we're in the process of collecting data. There's not a database out there that has everyone's biometric because there's a lot of issues relating to what do we do with that data. So if I'm going to collect some fingerprint data and I collect your hand and signature and face and iris and voice, what do I do with them and how do I look after them? So, because that's a lot of information you're giving me. But we actually need those databases in order to run fusion algorithms. And the idea here is that if it's in an environment where my hand isn't good enough, for example, this hand here is not good enough, we might be able to merge it with skin and weight the skin higher for me than the geometry for you. If it's iris, I might be able to take your face at the same time, seeing as I'm using a camera. So there are plenty of ways of doing that. All right, are there any questions? We have till 5:20. Okay. No questions? Yeah.
I mean, my hands are different. I mean, I can see the different size of the fingers, but that would not pick up as a difference in a hand scan?
Typically not. What we would do is you would align your fingers in the reader, and then for your left hand, we would turn your hand upside down, and it will create the same image. The only thing you'd have to take your rings off because that would obscure the camera light. But typically they are the same. You'd have to reduce the threshold slightly because it's very hard. In fact, it's not very easy to keep that hand flat. That hand is flat on the platen. And this hand, because your hand is not flat on the top of your hand, it's kind of hard. So you would need to reduce the level. But you could still gain access with your hand upside down in a hand geometry environment. It's pretty cool stuff. Any other questions? All right, so let's take a look at enrollment first. Enrollment is incredibly important. If you don't do this right, the rest of the day is really upset because you won't be able to do performance measurements on them. So you really need to know what you want when you enroll a person because you only get them once because it's really hard to get people to come back once once you haven't collected the right data. So I got to figure out what sample I want from you at the very beginning. I want to figure out whether I need to know who you are or I just need to have your biometric from you. So for example, if you need to get into this room and you're registered, what information do I need from you? Do I need to know your name, or do I just need to know that you're in this class and you dump your hand at the door and I grab that information from you? All right? I need to be able to figure out what my population is in order to make sure that everyone has all the biometrics that I'm going to be taking. If, for example, I have a hand geometry reader, I need to make sure on the height of the hand geometry. If I got iris, I got to make the position of the camera. And of course, we come in various sizes and heights, so that's an issue as well. I need to kind of get an idea of that. For example, if I'm going to put hand geometry in at a border control point, I need to deal with everybody. So typically, it's at this height, and people look down onto it, and that's an easy way of doing it, as opposed to having it at the 6-foot height where no one can get a hold of it unless you're 6 foot. We need to figure out how to create the template. You need to figure out how you're going to store the template, and you're going to have to figure out how you're going to protect that template to make sure that people don't grab that template and either delete it or use it for their own use. And you've got to figure out how many samples and the quality of that, because you really only get one time at this enrollment deal. And then verification is relatively simple. This could be /identification. We just grab the sample, we make sure that all the features are out, and we do this quality check. I'm just going to show you an example here. This is an example here of a poor quality fingerprint. So it's a relatively, you can see that's an 81-year-old fingerprint. And it's very hard indeed to grab those images. In fact, there aren't many databases with 81-year-old fingerprints in them in the first place. I think Purdue is one of the only ones that collects them. We have them all the way up to 101, and we've got them over a period of time. And this is very important for those people that are developing algorithms, because if you're dealing with algorithms and you're training your algorithm on the best quality fingerprints you can get, then when this one rolls along, you're going to be in a lot of problems. In fact, McDonald's stopped a trial of fingerprinting at their Fresno branch. They had a trial where you could put your fingerprint down and get your coffee, and that fingerprint was tied to your ATM card. You didn't have to carry anything with you. You just walked in there, dumped your fingerprint on the sensor, and you get your coffee. And one day, someone who was elderly could not go ahead and get their coffee, and they withdrew it immediately because people would say, oh, it doesn't work for me, and that's really not the focus of McDonald's customer service. So they removed it. And so there are issues associated with that. US Visit, for example, does not fingerprint elderly when you come into the country. Identification, you need to make sure the transaction is processed by the system, and you need to figure out these candidate lists as well. I mean, if you go to an airport and the performance pulls off 1 in every 10,000 individuals, that's still a lot for a throughput on an airport. It's going to slow things down. So you need to figure out how you're going to segment your audience. You don't want to search the entire planet for 300 people jumping on one plane. So you need to take that database and search only those 300 people. So when you board, the errors are likely to be a lot less. All right? And some of the issues with the ACLU and other people is not necessarily on the need to do it. It's the error rates of how, when you're pulling them off, I'm being subjected to double screening because the algorithm is not yet good enough. So those are issues. You can solve some of these issues by being clever and reducing your search database. So if you know who's going to jump on the plane, put them in the database of the day. Don't put me in there if I'm not going to travel till next Wednesday. All right? So you might need to be a little smarter on that. And again, quality checks are very important. And this all goes back to the enrollment. Make sure you have enrollment images that are the same as the verification images. If you've got a really sunny environment and you're taking photographs of people at the check-in, for example, check-ins are normally bright and airy. Security areas are normally dark. Those are going to be 2 different illumination levels. That's going to impact face recognition for sure. Okay, so those are some of the issues with performance testing. I'm just going to show you some graphs here. That's a graph that measures performance. It's a detection error trade-off curve. And these different biometrics, this comes out of the NPL study done about 5 or 6 years ago now. Each one of these is a different biometric. And this comes back to my question on which one is the best one. It depends on the error rates that you're looking for. And then you just go across and then you pick. Some of them jump over each other. Some of them are better than others. And this kind of diamond over here is iris recognition. So these are some of the issues that you have. Performance will change, and this graph will change depending on the people that you test, the number of people that you test, and also the algorithms that you use. Right? This could be a graph for different algorithms in the same modality. It's not. These are different types of biometric, fingerprint, face, hand, and so forth. Alrighty, that brings it to the end. If you need any more information on 345 or 545 or any of the classes that we have, or you need any more information about biometrics, go to biotown.purdue.edu, and there's a link from CERIAS' website as well. Any other questions? All right.
Thanks, Steve.
Thanks a lot.